Hi everyone, I'm very excited to talk about my next series on harness engineering with LangChain Deep Agents. Just a bit of context, I was talking to one of my friends and he asked me how do you evaluate a long running agent which has like thousands of turns and tool calls and everything. And I did not have a good answer because a lot of the agents that I have been building were essentially not like coding agents or not long running agents, but more of vertical B2B agents, and they tend to be relatively simpler. But taking that as an opportunity, I was trying to understand how do I go and learn harness engineering and evaluation on long running agents. And I happened to stumble upon LangChain's Deep Agent, which is its version of coding agent and long running agent. And therefore, that's my goal, to explore it and actually make it working on a benchmark and improve it. So this is my forked version of LangChain Deep Agents. It's basically a completely open source agent harness. And when I say harness, it means that it comes up with the core agent loop. We'll talk about it more, but all the primitives that today's modern harness needs to have, like subagents, file system, context management, access to shell so that they can run bash commands, skills and whatnot. And my overall goal in these 10 weeks is going to be to understand the LangChain Deep Agent harness code, just so that I understand how these primitives come together to build these harness. You can think of this as very analogous to what Claude Code or Codex harnesses will be, and coding agent harness are like very advanced, way ahead of any other kind of agents. So that's what my goal will be, to learn about this open source harness, get comfortable with evaluation. So LangChain is a full ecosystem. So they provide something called LangSmith, which is essentially an observability product, and it helps you analyze traces and how is the harness running when it is given a task. So I want to get comfortable with that as well. And then I want to evaluate it on a public benchmark. So TauBench or something I'll pick up, and I'll evaluate this harness with different models on a TauBench or a public benchmark. And then I will be actually trying to improve on the benchmark by making changes to this harness. So that will be the hard part and the interesting part, because if I could choose a lower model and try to understand its traces, where it is failing, and then try to see if I can make some changes in the harness with a lower model, and can I improve it on the benchmark. So that will be my 10-week series of learning. And today I'll be in the week 1, I will be talking about how Deep Agent harness works. So I've cloned it locally and running it locally. So we'll talk briefly about how Deep Agent harness works. And in the step 2, I will be taking example of one Deep Agent harness called Deep Research Agent. This is, think of it like a chat GPT, Deep Research Agent, and so on. This is given in the examples of Deep Agents repository. And we'll be discussing it, how it works, and then I'll be adding a skill to it and make sure the skill works, and then evaluate it on traces. And I will use two models, GPT 4.1 mini and GPT 5.5, which is more powerful model, and 4.1 mini, which is the older gen model, and see like if my skill is working properly or not. So let's talk about the step 1, which is discussing how the Deep Agent harness works, understanding it. And first I'll show you a diagram which will make it very easy intuitively to understand. I'm using TLDraw for it, and then a little bit of code so we get the intuition, and then we'll actually run it and see how it works. I'll be taking example of Deep Research Agent. Think of it as ChatGPT Deep Research Agent, which basically you give it a task and it spawns a lot of sub-agents to be able to deep research on some topic and bring you a proper report. Slightly more deeper, and it does more searching and thinking, spends more time than a simple web search. So let's take a look at how does the Deep research agent is assembled and executed. So first, the core concept. The core concept is very simple in all the agents. Looks deceptively simple. Of course, the agent does a lot of things behind the scenes, but it's basically a core loop of model and tools plus a lot of primitives, and these primitives are increasing as the agents are getting more and more complicated and handling more and more complicated tasks. So whenever Claude, Anthropic or OpenAI come up with some LLM which is more powerful, they have to look at how do we make sure that the harness or scaffolding around it has the right primitives so that it can extract the power of the LLM. That's why all of these instruction set, memory, skills, file system, compaction, all of these are coming because these labs not only have to build powerful LLM models, but they have to actually showcase what these powerful models are capable of. And they are capable of doing reliable, big, long-running tasks reliably. And that's their goal. So they have to build a lot of these harness and primitives to showcase, which is what is Claude Code, Codex, and Codex Work, and Claude Cowork, and whatnot. At a high level, as I said, the core agent loop is model, tools, and it just keeps taking your question and planning and thinking and acting and repeating. And that's what the core agent loop is, and a lot of primitives that we talked about. So if you look at, if you try to go more deeper into the deep agent harness, there are three layers that it provides. The first is, and I'll go bottom first because that's more fundamental. So LangGraph runtime, this is basically as your agent loop is running. It basically, so when I say agent loop, it's like LLM called and then it figures out I want to use a tool, or I want to plan, or I want to give the answer, and it keeps doing these things again and again and again. So all of this is maintained is LangGraph runtime. There is nothing new in this. There's always existed. LangGraph, LangChain frameworks is built on top of LangGraph runtime, and it manages these loop iterations, stores them, and ensures that if anything goes wrong, it can power up from whatever that is stored. So this is like the core engine where the agent is running. And then you have this LangGraph framework. This is basically, again, so it provides the core interfaces. So it provides you like chat model, you can provide the model GPT 5.5, you can provide your tools as functions, or bring in external tools like Tavily is a web search tool, and you can bring all these standardized primitives. Deep agent harness, or the middleware and the backend. Deep agent harness specifically, as I said, is built on top of LangChain framework and runtime, and actually is a lot of scaffolding around these two layers so that powerful LLMs can do long running tasks, which is like coding agents. So Deep Agent Harness adds a middleware, and it has hooks, and middleware provides a lot of these things like memory, skills, file system, sub-agents, summarization, and so on. And it injects tools, memory, skills into the runtime, and handles summarization, and so on. So these are three layers of the Deep Agent Harness, which is the core Deep Agent Harness, LangChain framework running on LangChain framework, which runs on LangGraph runtime. Now that we understand how the Deep Agent is assembled, let's see how it gets executed. So when it gets a task like deep research and quantum computing breakthroughs, the main agent, which was created using this model tools, it can also spawn sub-agents like dedicated research sub-agents and skills. It has this instruction loaded into the LLM's context window, which clearly instructs us that when you get a deep research request, you have to create a plan. You have to save that plan, which is the list of to-dos. And then for doing actual research, you should always spawn these sub-agents, dedicated sub-agents for research. And your job is to synthesize all of it and write the report and then verify. Now, what are these research sub-agents? These are these dedicated sub-agents whose only job is to do on a deep research on a topic. And they are very simple. They don't spawn sub-agents and all. They simply have two tools. They can do two things. They can search and they can think. And but they can keep doing in the loop for a long time. And this main orchestrator agent can spawn n number of research sub-agents. So what happens is when you get deep research on quantum computing breakthroughs 2024, if user passes this, it basically the main agent, the orchestrator agent, which is the deep agent, deep research agent, it basically figures out that creates a plan, puts them in a to-do file, and then spawns a lot of research sub-agents. So that could be like understanding the history of quantum computing, understanding its current state and breakthroughs 2024, figuring out the future outlook and whatnot. And then each research sub-agent can do search and can think. And then it keeps doing that for a number of iterations till all three of them are satisfied. And then finally go to the main agent, which compiles, synthesizes, and writes the final report. So this is overall how a ChatGPT deep research agent works. Of course, it is more complex than this, but this is the core ethos, where if a user gives a task, it breaks it down to a to-do list. It spawns specific dedicated search agents with search queries. They do their own deep research, and the main agent sort of synthesizes all of it. So let's look at how in the code it works. So as I said, we'll look at a little bit of code as well. So this is the agent.py of deep research agent. It's provided in the examples session of examples folder of a LangChain Deep Agents harness. So this is what I talked about. It's a simple agent that's constructed from the model, from the tools, system prompt, instructions, sub-agents, backend, and skills. And this is the deep research agent. So the orchestrator agent is the main one, and this is the specific research sub-agent whose only job is to do specific research on a particular topic. And it has only two tools. It can think and it can search. And all of it is constructed from LangChain framework, but the deep agents harness library from which you can load the deep agent and file system backend. And this is where all the instructions are. So you can take a look at how it stores the instruction. So this is the research workflow. As we talked about how it guides the agent to go about doing the research. So it needs to plan, save, research, and it also provides research planning guidelines, and whole of this prompt or essentially is loaded as a system instruction into the agent. And that's what the agent then follows. We talked about LangChain's deep research agent. So let's now run it and see how it works. So this is basically LangSmith, which is the observability tool of LangChain. And what I'm going to do is I'm going to pass it a deep research task. Do research on quantum computing breakthroughs in 2024. So I'm going to submit it, and you can see that this has started running. So it first loads, it is loading the deep agent model, and you'll see here what right now it is calling a tool. So the deep agent harness is getting assembled. The model we are using here is GPT 4.1 mini. It will do a lot of things here, as you will see, and call a lot of LLMs and models and tools. So you'll see something as simple in the code. Behind the scenes, it's a lot of power to the model to define its own path and charter its own path. And I believe that's where the harness philosophy comes, that you have to harness the power of the LLM to solve a big task and just provide it the right tools, skills, instructions, and runtime to be able to work. So as you can see here, it has done some kind of a summary. Great. So it was able to run. So you can see this was the final research, and this is the research that provides a comprehensive overview of what quantum assisted machine learning is and whatnot. But that's not the important piece. The important piece is, like, if if you really boil it down, it's basically this is my prompt and it gave the output. And if I see what happened behind the scenes is the skills middleware, there's a lot of deep agent harness tool call, there was planning, and there was final report that was generated. So let's look at the trace of what we have ran so far. So what we did is we gave this task, do research in quantum computing breakthroughs 2024 to Deep Research Agent. It ran for 60 seconds, as you can see in this waterfall viewer of LangSmith. So out of 60 seconds, the first time is the model spent 3 seconds on, it's the main agent which is thinking that what should it do with this task. So once it gets this task, it's basically thinking, okay, I have these sub agents, these tools, what should I do with it? The thing that it does is it creates a task which is essentially a research sub agent, a dedicated agent that we had given, and assigns this query to it. So conduct comprehensive research on quantum computing breakthroughs, focus on latest advancements, key discoveries. This is something I did not give. It's the LLM decided that I will spawn a sub agent, which is a dedicated research agent, which will do properly this research and provide a detailed summary of the findings back to the main agent. So this is this research agent, and this research agent ran for 49.73 seconds. So out of 60 seconds, this research agent, which actually did the research on a comprehensive research, naturally spent most of the time. The remaining time out of these 10 seconds was spent in, as you can see, 3 seconds in the model, 6 seconds in the, again, when the research agent came, the main orchestrator agent was compiling this research and giving the answer. So if you drill down into this research agent, it does a lot of things. It calls a lot of tools, to-do list tools, Tabili search, which is the searching in the web, and then compiling, and then you'll see in between it has think tool as well. So this is a think tool. So it is thinking, searching, thinking, searching, thinking, searching, and it keeps doing in the loop for so long. And this is where obviously the deep research spends the time. And then finally it goes to this model, which is the final model that is actually summarizing it. So this particular model again calls, this is your main orchestrator agent, calls ChatGPT OpenAI, and essentially summarizes, synthesizes all of this into the final report. So this is what happens when you simply pass a small query like do deep research on this. This is obviously much simplified version, but overall a ChatGPT deep research kind of agent from one query is spawning a lot of sub agents, doing a lot of deep work, and then synthesizing and bringing it back. And that's why evaluations is becoming harder and harder, because these if you look at it, the agents are solving more and more complex problems, and that means the traces are becoming very, very large and very complex, and the agents are defining their own trajectory. So to be able to contain these, what I call beasts, you need a lot of evaluations and understanding of the traces, and then being able to figure out where the agent is going wrong. Without babysitting them, how do you provide the right kind of instruction guardrails so they do better? Great. So we've completed the step one. We discussed about how a deep agent harness or LangChain Deep Agent harness works, which is a coding agent and harness, and essentially long running agent harness. How does it work? We took example of a deep research agent, which is basically does it's like a ChatGPT deep research and spawns a lot of sub agents and then combines and synthesizes into a report. We looked at how it works diagrammatically so that we can build the mental model. We also looked at it slightly at the code, and then we finally ran it from LangSmith DB and observed the trace. And I feel this what closes the loop for this first video. As I said, that building long running agents harness such that these complicated tasks can be done reliably. needs a lot of understanding of these modern harness, how the system works together, and then understanding their traces and understanding where the agents are going wrong, because these traces are becoming huge and the models are running for longer and more complicated. And to be able to evaluate these traces both using LLM agents as well as a human reviewer, you need the human in the loop here. And to be able to improve these harness so that the model can do the task reliably, I think that's a very important skill in harness engineering, which is what we learned. Next video, what we are going to do is I'm going to make a change on this dip research agent. I'm going to add a skill which basically not only runs this report, but actually adds a verifier skill which will independently verify this research report. And that's the skill about. And then we'll evaluate the traces, and I'll actually show it to you that if you use different model, how a powerful model like GPT 5.5 is making much better decisions on when to invoke the skill versus an older generation model. This is also great learning because as the models are becoming better and better, they are in a way eating the harness. And it's important that with time, your harness on a already defined task should get thinner, but then your agents should get more and more ambitious and should solve more and more complex tasks, because the model is becoming powerful. So thank you.